Here in this video, I'm going to continue to look at some polynomial inequalities. And you'll notice with this example, we're going to end up with four terms. We have an x cubed. So we have 2x cubed plus 13x squared minus 8x is greater than or equal to 52. Well, again, the first step is to set this equal to 0. So we're going to get 2x cubed plus 13x squared minus 8x, and we want to subtract over the 52, so it's now equal to 0. Now at this point we need to find when is this polynomial going to be equal to 0, because again we want to find our test intervals, test values, the polynomial values, and then make our conclusion. So how do we go about solving for x? Well, if you notice here, we actually have four terms, and the technique we're probably going to use is grouping, where we can group the first two terms together and the last two terms together. Now notice this is a negative 8x. I'm going to group that negative with the 8x because that's going to go together, and I'm putting a plus in the middle. So be very careful when you do this grouping. A common mistake is to leave this negative out here, but if we leave the negative in front of the parentheses, that's going to make this a negative 8x and a positive 52. So this is why you actually want to take the negative and keep it with the 8x. So now that we have this group together, what can we factor out here? Well, we have an x squared in common. So we would end up with 2x plus 13. And over here, we can factor out what's going to go into 8 and 52. It looks like we could factor out a negative 4. And we'd be left with 2x and a positive 13. And now we have a 2x plus 13 here, a 2x plus 13 here, so we can factor out the 2x plus 13, and if we take that out here in this first grouping, we're left with the x squared, and over here in the second, we're left with the negative 4. From here, we have 2x plus 13, and we can go a step further. X squared minus 4, if you recognize this is a difference of squares, so we could factor this to x plus 2 and x minus 2. And now we can identify the zeros. So if we set this equal to 0, we'd eventually get what? X is equal to, move the 13, so it's a negative 13 divided by 2. X would be equal to a negative 2, and then if we move the 2 over, x is equal to a positive 2. So this gives us our zeros where the graph could possibly change sign. So now we can set up our test intervals. And once again, we're going to start from negative infinity. And we're going to go up to the next number, which would be the negative 13 halves. That would actually be a negative 6.5. And then we want to go from a negative 13 halves up to the negative 2, negative 2 to positive 2, and then 2 to infinity. So then we want to pick our test values. And again, your test value can be any number in the interval, and to make this easy, if this is a negative 6.5, then I'm going to go just to the left of that and pick a negative 7. And then here I would pick negative 3, and 0 is the easiest between negative 2 and 2, and then here simply 3. So now we want to determine what is the polynomial value. So again, remember, we're going to plug the test values into this polynomial and find out what we end up with. Now, to make this easier again, you can simply plug in each value, but I'm going to go to the calculator and type this in just like we did before. So if we go to y equals, make sure I type this in correctly, we have 2x cubed plus 13x squared minus 8x minus 52, and we're going to go to the table and let me delete what's there, and we want to plug in our test values. So we want to plug in each of the test values. So we would plug in, let's see, -7, -3, 0, and 3. So -7, -3, 0, and 3. And we get out -45, 35, -52, and 95. Now, once again, even though we're getting out these values, we're more concerned of, is it positive or negative? So then our conclusion is negative, positive, negative, and positive. Now, when we're looking for the solution now, we need to recall, what do we have for the inequality? Well, for this one, we're looking at greater than or equal to. So the endpoint's going to be included, and we're looking for values that are greater than 0, so that means we're looking for positives. So that means we're looking here, which would be this interval, and here, which would be this interval. So therefore, the solution would be bracket, because it's equal to, -13/2 to -2, close the bracket, and we're going to union that, or with 2 to infinity. Now, you'll notice, just as a reminder, I put parentheses on infinity because we actually never get to infinity. So anytime you have a negative infinity or positive infinity, you're simply going to use parentheses. So this would be the solution for this particular inequality. And again, you could always look at the graph of the inequality, and let's quickly do that. If we were to graph this, and we can see it's going off the screen, but we're really concerned about where is this going to be less than 0. So let me try to zoom. I'll just try to zoom out a little bit. And you can see a little bit here, -13, so a -6 to a negative, roughly -6.5 to a -2. And I may zoom back in to see this a little bit better. We can see here at a -6.5 to the -2 that the graph is up here above the x-axis, and then again over here at 2 to infinity, it's above the x-axis. So that verifies that our solution is correct. All right, let's look at one more example. Let's look at x squared plus 3x plus 8 is greater than 0. All right, so once again, this one's already set to 0, so we want to factor this. So is there any way that we can factor this polynomial? Well, obviously x and x, but now what's going to give us 8? The only thing we have is 1 times 8 and 2 times 4. And there's no combination there that's going to give us the 3x that we need in the middle. So it doesn't look like this is going to easily factor. So we may want to use, if you recall, the quadratic formula. That is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So if we go to use that, then we now have here a is 1, the coefficient of x squared, b is equal to 3, the coefficient of x, and c is equal to the constant term 8. So we would get x equals a negative b, so that's a negative 3, plus or minus the square root of b squared, so that's 3 squared minus 4 times a, which is 1, times c, which is 8, divided by 2 times a, which is 1. And if you work this out, you're going to end up with 3 squared, which is 9, minus 32, which is going to turn out to be a negative 23 over 2. Now, because we have a square root of a negative number, this tells us there are no real zeros. So basically that means the graph never touches the x-axis, which means your graph is always going to be positive or it's always going to be negative. So if we look at this graph, if we go to the calculator and we type in x squared plus 3x plus 8, and I'm going to go to zoom 6 to zoom standard, and this is a perfect graph here for us. Let me copy this over here. And if we look at the graph here now, we knew we was going to have a parabola and it's opening up, and this verifies that we have no real zeros because this graph never touches the x-axis. And because the graph is opening up here, then that tells us there's no solution. Because if you recall, there's many solutions, I should say, because this is greater than 0. This graph is always above the x-axis, so that means the solution then would simply be all real numbers. We could say that would be negative infinity all the way to positive infinity, because any value for x is going to be greater than 0 when we plug this in to x squared plus 3x plus 8. And graphically, to represent the solution, if we looked at the number line, then that means we would shade in the entire number line because the solution, once again, is all real numbers. So here's the example where any value of x is going to make this polynomial true.